In this section, we're going to take a look at the last hypothesis test that we're going to cover this semester. It has a lot to do with, obviously, all the material that we've been talking about up until this point. And I have kind of these pictures down below to help at least start to illustrate the main idea of this section. Our goal in this section is to try to understand that if I have a population of data, like over here at the right, you can see I have maybe a bunch of individual dots that are put into this scatter diagram. And maybe each one of them represents an employee at a company. Each employee has been at the company for a certain number of years, and they each make a different income level. And it seems like maybe there's a general upward trend to the data. Now again, if this is a population, we can assume that this is all employees. And what we've been doing over the past several sections is we've been going to a population and we've been selecting a small sample and viewing those sample dots in a scatter diagram. And what we can see is that in both pictures there is going to be a line of best fit that we can go ahead and create once I have my data points. Now the line of best fit that I have in the population and the one that I have over in the small sample may or may not be the same. In fact, chances are they're going to definitely be different. So our goal in this section is to say, if I don't know what the picture in the population is actually looking like because I don't have all the dots, then can I go ahead and by using a small sample of points, can I make an educated guess as to what I think is going to be happening with this line over here? Specifically, what we're going to be focusing on today is if I understand what this slope of the sample line of best fit is going to look like, then can I make an educated guess as to the slope of the population line of best fit? So as I state down below, we should be aware that both of these pictures can have a line of best fit, and we're hoping that what we see in the sample picture will help model what is going to happen in the entire population. So to do this, we're going to be going ahead and talking about these different lines of best fit that we have in each picture, and we'll also note some change in notation. Now it seemed like I might have had a small typo in a version of the notes that I had pulled up. You might have already had a fixed version, but this should say that in the section 11.1 we found the following line of best fit formula that came right off the calculator. This was our a plus bx. B represented the slope and a was a portion of the y-intercept. It was the y-coordinate. Well, in section 11.4 and in section 11.5, we would use this formula to represent the line of best fit. Notice that B1 and B are kind of playing the same role because they're ultimately the thing that's just being multiplied to x. Whereas when I look at the thing called A and this B0, they're playing the same role. They're the thing that's being added. So there's just a small notational switch between these green things and blue things, and we swap over to just this B0 and this B1. Our focus today, again, is going to be on this B number 1 in blue, the slope of this sample line of best fit. So what's important to keep in mind, though, is that these values of B0 and B1, or A and B, those are computed from sample data. Those are the y-intercept and the slope for our sample line of best fit. And so they're ultimately sample statistics. They depend on the sample. If I had a different sample of points up here, I might have gotten a different line with a different slope and a different y-intercept. So, while it's the case the sample goes ahead and follows this particular formula for the line of best fit, there's also a population line of best fit. And so you can see here I've used kind of like a capital B1 to stand for the slope of the population, and a capital B0 to stand for the slope, or sorry, the y-intercept of that population line of best fit. So ultimately, we're going to be using B0 to estimate capital B0 and B1 to estimate capital B1. Specifically today, we're going to be focusing here on the B1s because those are our slopes. And so we're curious, how do those values behave? Well, it actually turns out that B1, this little sample slope, changes every time I take a new sample, acts as a random variable, and it follows a t-distribution. If you take a look at the next page, you'll see kind of the general overview that we have for this hypothesis test. Again, our goal is to try to make a guess as to what we believe is happening with the population slope. So our hypotheses are going to state that the population slope is 0. Notice that's true for each one of our null hypotheses. And our alternative is that the population slope is maybe a negative number, a positive number, and over here just something besides 0, so negative or positive. We can often think about these as implying certain types of relationships between the variables. If I have a line of slope 0 in the population, it means that I have no relationship between the two variables. Knowing something about x doesn't help me predict y. If I have the slope being negative, then I'm going to have a negative relationship. That is, all my dots I could imagine going down over time. Over here I have a positive relationship, and in this final one again I'm going to have a negative or a positive relationship. So these are the hypotheses that we'll set up for this test. If I take a look at the next step in doing a test statistic, I'm going to have to enter some data into lists to run that lin-reg t-test that we've been using for the past couple sections. I need to make sure that I have paired quantitative data, and if you take a look at checks 2, 3, and 4, what we'll see is that these checks here are really going to require that we're able to understand information from 11.1 through 11.3. That is, we need to understand how to make a scatter diagram. We need to understand how to make a residual plot for a normal probability plot for residuals and a residual plot. So I have all of these things here that I need to make. And these are all the different pictures that we've talked about over the past couple sections. So the checks here are probably the longest and most annoying part of this test. Then I'll have a test statistic. It's going to be calculating a t-score for our result. Once I have that, I can go ahead and analyze the data. And again, what I'm going to be attempting to see is how weird would it be to get a particular sample slope if I believe that my population slope is 0. So we'll go ahead, draw a picture, and reach a conclusion, just like we have with every hypothesis test thus far. In the next video, you'll see that we'll go back to the CAR data that we've used for the past several sections and try to see how we could actually use this to see if we can test for a negative linear relationship between these variables.